Greetings and welcome, friends. Mr. Watty here. We are going over the quest. We were talking about, like, things and stuff with circles. I don't remember what it was called. What was section 10.5 called? I already forgot. It was a thing about circles, though. You know what I'm talking about. So here it says a line T is tangent to the circle. Find the indicated measure, D, E, F. So this major arc is what I'm looking for. Right, whoop, like so. And what we realized was that this angle of a tangent line to this chord is going to be half the measure of its intercepted arc, is what we realized. The way that this makes sense to me, Malik, is that these two angles are a linear pair to each other, and they add up to 180 degrees, whereas these two arcs, the major arc and the minor arc, add up to 360 degrees, which is twice as much as those linear pairs. So if I double 117, what's that going to be? 234 degrees. All right, so that's not too shabby. Let's take a look at question 8. Find the value of x. Now, sometimes, and I saw you guys working on one of the problems yesterday, sometimes a problem becomes easier by introducing more variables to it. So if this is angle x and this is angle y, what could you tell me about y in terms of x? What is y equal to? Okay, so yeah, you're already jumping ahead of me. You're going there. I was thinking of just these two. Haley, what was your thoughts? 180 minus x. I was going for the linear pair because I realized it was more helpful for me to know this angle y than it was for me to know that x angle. So y is going to equal 180 minus x, and like we said, y is going to equal 1/2 the sum of these two arcs. All right, so 2x minus 30 plus 30, like so. I can substitute 180 minus x in here. Equals 1/2 of, those 30s cancel out, 2x. So it looks like half of 2x is just x. 180 minus x, add x to both sides, and we get 2x, divide by 2. Looks like x is equal to 90. Wow, interesting. That means that these are perpendicular to each other. Huh. Excellent. Don't be so surprised. Yeah. All right, now we had another theorem that said that if my two secant lines intersect outside of a circle, so notice point C, the intersection is outside of this circle, that it will be half the difference of these two arcs, the bigger arc minus the littler arc. So I'm going to have x over 2 is going to equal 1/2 the difference of x plus 70 minus, and x plus 30 is all being minused, subtracted even. So be careful about distributing that sign there. That minus sign is going to apply to both of those. That's really kind of the biggest trick of this whole problem right here. And I'm going to get 1/2 of x plus 70 minus x and minus 30. So that's going to equal 1/2 of x minus x. Oh! Hey, wow, that just zeroed out right there. And 70 minus 30 is 40. So x over 2. I saw some people, I believe, multiply both sides by 2 here, which I thought was a great strategy. But even if you didn't notice that, half of 40 is 20. And then you'd multiply both sides by 2 here anyway, and you get x equals 40 degrees. Right? Let's see. Ooh. Let's see. This is what you think about when you're on a cruise vacation. You are watching fireworks over the San Diego Bay S. All right. I believe that they have the ocean, they've got the crust, and then like that mantle thing, and then like the core, and then like this is like the nougaty center or the Tootsie Roll center of the Earth, as they've scientifically proven by now. The thing they don't know is how many licks it would take to get to the center of the Earth. Right, but if all of humanity simultaneously worked together and took shifts licking the same spot on the planet Earth, are you saying ew because of like germs? Okay, not because of like dirt in your mouth, or like, all right, or like just like licking granite over and over when you hit whatever rock you find. But anyways, lick to the center of the Earth. Oh man, that'd be crazy. So anyways, you are not licking to the center of the Earth. You are watching fireworks from a boat. The highest point the fireworks reach is F. Above is about 0.2 miles. Let's see, let's label these. So here's 0.2 mile firework high show. Hooray! Your eyes... Yeah, you are, if you're on this end of the boat, you are the king of the world, but you are not enjoying fireworks. So, that's too bad. Your eyes are about 0.1 mile above the water. So here's this distance is 0.1. Wait, what? Okay, I was going to say, I was like, that's a tall boat. 0.01. Thank you, Anthony. At point B, you can no longer see the fireworks because of the curvature of the Earth. The radius of the Earth is about 4,000 miles. That's a good one to know, right there. Yeah, so how many licks would it take to get like 1 foot deep into the Earth and then just like divide that into 4,000? You'd figure it out. Assuming a uniform density, but that's not the case. So let's see, and FE is tangent to Earth at point T. Okay, here we go. So let's see, find the measure of arc SB. All right, so that's what we're actually going for here. Guys, I have a feeling we're going to have to... Didn't most of our theorems relate to angles yesterday? I have no angles right now. Did anyone notice that? The lack of angles? Intriguing. I do, however, know that this is a right angle right there. So let's see. I'm thinking of using a trig ratio. Let's see, if this is 4,000, what's SC equal to? Also 4,000, and the same for BC, 4,000. So I believe we could do some trig here and find the measure of C and the measure of, or actually, yeah, this angle and this angle, and add them together, and that's going to be the measure of the arc. Is that the way that they wanted us to do this problem, using trig ratios? Because I feel like I'm not actually using any of their theorems, but that's fine. So, from this angle's perspective, the acute one, all right, angle FCT, I have the adjacent is 4,000, and the hypotenuse is 4,000.2. What trig ratio compares adjacent to hypotenuse? Cosine of, I'll call this, there, I wrote with yellow on yellow, x. So cosine of x is going to equal 4,000 over 4,000.2. And I'm going to cos inverse both sides. You guys remember this? It's come back to haunt us. We buried trigonometry in the center of the Earth, but it somehow found its way back. So let's see. So I'm going to take the cosine inverse of 4,000. I wonder if my calculator is even going to handle this that well. Over 4,000.2, close parentheses. And I got x is equal. 2. Right. Okay. 0.5729 degrees. Big idea right here is this is not to scale. Notice that I'm about half a degree. This angle looks like it was going to be like 57 degrees. Not to scale. Not to scale. Okay? Yeah. Yeah, yeah, yeah. So there's one angle. Let's find this angle over here, y, that I called it. So that's going to be 4,000 to 4,000.1. It'll be much the same math. Cozy is going to equal 4,000 over 4,000.1. And I get y equals about... Actually, I should have had a squeakles there, shouldn't I? Squeakles. And I got 0.4051. I did it. Man, Anthony with the save. Thank you, Anthony. I don't know what I would do without you besides being off by a place in my angle. Let's see. Okay. Undo. All right, so 0, 1. Man, Anthony with the save. 1281 degrees. And if I add those two together, I should be able to find the measure of this entire central angle. And how is that central angle going to relate to the arc SB? Anybody? How is the central angle going to relate to the arc SB if I knew this entire angle? A central angle is exactly equal to it. So I'm going to add 0.1281 with 0.5729, and I get 0.701 degrees. They want it to the nearest tenth, 0.7 degrees. So that's the measure of the arc. Let's see, let me, while we're here, blast. All right, bye, internet friends.